Hello students, welcome for the AIC Pradana GATE training program. Today we are going to see subject on computer networks on topic data link layer. In that we are going to see the medium access control, that is MAC protocol. We are going to see something about the MAC protocol today. Very interesting topic, and of course, so let me go to the topics. Okay, so we'll discuss some GATE questions related to it, and that will be very easy for you to understand and to solve some of the GATE questions related to this topic. Thank you for joining, and let me go to the session. So typically, when I start the session on data link layer, as I said earlier, video, this is the second layer of the OSI and is responsibility to for framing, error control, and flow control. Okay, so and as well as the access control. Now we are going to see something about the access control, how the we are going to control the access, because it is the data that is to be transmitted between the sender and receiver. It is going to happen in a shared medium, and how in a common channel, how the each and every node is going to access its own path for transmitting the data. So that is something about the medium access control. So that is what we are going to study today. Okay. So let me see medium access control. So in most of networks, so we have some there are some multiple nodes that share a communication medium for transmitting their data packets. So probably the main responsibility of this MAC protocol is regulating the access to this shared medium. Okay. Okay. So here the choice of this MAC protocol can be directly bearing on the reliability as well as efficiency of the network transmission, because there's a possibility we have errors and interferences as wireless communications due to some various challenges, as well as the energy efficiency also affects these design of this MAC protocol, because the great energy efficiency or increased in latency or a reduction in throughput or in regardless to the fairness, of course. Okay. So because since multiple nodes are there, then they are going to share a common medium normally, or in order to tackle all these challenges. So there's a possibility for a collision to happen. So by the diagram itself, you can come to know that there's a possibility of collision to be happen. So it is not, the data transmission cannot be take place at the same time. Only one node can successfully can transmit at a time. But how this could be possible? If there is only one node is given a chance, what about the other nodes? How to provide the access? How to regulate this access for all the nodes to communicate with no collision? It's collision free, with contention free. So how this could be possible? So dealing all this one is done by the important protocol, that is something about the MAC, medium access protocol. Okay. So the main responsibilities of this MAC layer is it decides when a node accesses a shared medium. That is the main responsibility of this MAC layer. So MAC layer's responsibility is when a particular node accesses shared medium. Okay. So here, as I said before, so when a collision occurs, what happens? So as well as next is it resolve any potential conflicts between the competing nodes. It resolve any potential conflicts between the competing nodes. And it also correct communication errors that occurs at the physical layer. And of course, it perform any activities like framing, addressing, as well as the flow control. So these are some of the responsibilities what does this MAC control have. Okay. So that's from this also we can come to know that the main task of MAC protocol is to minimize the collision. That is the main task, because the collision happens due to the shared medium and coordinating the multiple access of the shared medium. So there is a responsibility that we have to minimize the collision. So in order and also have to efficiently use the bandwidth. So when so the main task here of this mapping overall, when say talk about this, is determine when a node can use the link or the medium what we are going to use, and what a node should do when the link is busy, and when what the node should do when it is involved in collision. These are the important main task of the MAC protocol. Okay, a part of the responsibilities of MAC protocol, what I discussed as such of deciding when a node can access, resolving the conflict, or correcting the communication errors at the physical layer, or performing any activities. So the main task is these are some of the main tasks of MAC protocol: determining when a node can use, and what to do when the link is busy, and how to solve if there is a collision happens. This is the main task of the medium access control. Okay. So there are three ways of sharing the mediums. Where we have normally go for three ways in solving the medium. Okay. So what are the three ways of solving the medium? One is the channel partitioning of MAC protocol, where the channel will be efficiently and fairly it has been shared among the multiple users, and so that what happens in this, by doing so, if there is an inefficiency at low land, there will be in delay. Of course, these are some of the drawbacks that happens when partitioning this channel. And of course, next is taking turns, taking turns. That is, it checking, giving its chance or giving the generating the opportunity for the particular medium to use, for the particular node to use the medium. Okay, so that is providing some reservation technique for the particular channel. I mean, for the particular node to use the channel for its communication. Okay, so this is something about the taking its turn. And the third one is the random access. That is a MAC protocol that is being used for this particular thing. That is efficient at low load, as well as it is high load. At a high load, there is a collision overhead will happen. Okay, using the random access matrix. Because the next few topics we are going to see these topics, these things in the next few minutes. We are going to see these three ways to share the medium. We are going to see in detail. Okay. So these are the broad classes. That is channel partitioning, dividing the channel into smaller pieces and allocating the pieces for the efficient use, and random access, the channel that is to be divided, and to perform not to have any collision, and if suppose if there is any collision, how to recover from the collision, and taking the turns, and that is the nodes which have the opportunity for reservation is being provided for to use this particular channel for communication. So this is the taxonomy of multiple access protocol. The taxonomy of multiple access protocol. So previously, as I said, the three classes. One is the random access, controlled access, and another one is the channelized protocol. The random access, randomly when choosing and accessing is, we have some certain protocols to be followed. That is Aloha, fluorescence multiple access, CSMA by collision detection, and CSMA by CA. And for the control access protocols, we have some reservation, polling, and token passing, as well as the channelized protocols. We have FTMA, TDMA, and CDMA. So from this, it has been clearly said that the random access protocol, because randomly accessing in the sense that there is a possibility for the consumption to take place, because each and every node needs its opportunity to transmit the signal. Okay, so it will, that is, and of course there will be some contention, so that has to be resolved. And how the things are, what is the solution by resolving and providing the opportunity for all the nodes for accessing the channel and sending the data is a great challenging task here. So that is the random access protocol. Whereas in the case of controlled access protocol as well as the channelized protocol, it is contention free, so that we cannot see the any contention, because we are because in prior we are given some reservation and polling and all this done, and based on that automatically the data will be shared and accessed. Okay, the channel will be accessed. So there is no that much contention happens at the control access protocol as well as at the channelized protocols. So like now we are going to see each and every protocols in depth. Okay, so about the first, let me see something about the channelization protocols. Okay, talking about the TDMA, time division multiple access protocols. Okay, so talking about this time division multiple protocols is more flexible than compared to the other protocol, because here all the technologies are allocated with a certain time slot for communication. So we are giving some certain time for the channel, for all the channels to communicate. So that is controlling by using the TDM, time division multiplexing access. We are giving some certain time for all the channels to communicate. Okay, so now there is no need, like okay, here the receiver can stay at the same frequency at the whole time. So that is the main concept. Okay, so here here the so only the time slot is being provided, so we can able to say okay, it can stay at the same frequency using one frequency, and thus every single simple receivers and transmitters may use different algorithms to control the medium access. So that is the advanced advantage of using this TDMA concept. Okay, so listening, but it is using this particular TDMA concept. So we can see all the senders and receivers are well synchronized at each and every time turbine. Okay, they should be in a fixed pattern for allocating of certain time slot for the channel. by using some dynamic allocation scheme. So for the allocation of the channel, we are using dynamic allocation scheme for allocation of channel for certain at certain time slots. So there is no need for the sender and receiver to switch on to different frequency. He can stay on to the same frequency but use the channel at different time slots. Like for example, 1 to 2, 1 to 2, one channel one node can use the particular channel, or 2 to 3, one another channel can use. Example I'm talking about, or 3 to 4 another at this particular time slot. Another node can takes its turn for communication. So this is that. So the only time is been slotted and it is provided to the particular node, and whereas the frequency is going to be the same. So for example, this is an example that has been given for the time division. So totally there are of about 6 stations, and in the six stations, the time slot is given for the first, third, and fourth packet. Okay, whereas the slot two fixes are idle here. So they will take the response have this own time slot for its transmission. Okay, next the concept is the FDA, frequency division multiple access. Okay, so frequency, talking about this frequency division multiple access. Okay, so frequency division multiple access, as we all know that. So this here we have some different here this particular scheme is allocate some certain frequencies for the channels to transmit. Okay, it will allocate some certain frequencies, but here it can be at the same time. Okay, at the same time allocating. So here you can when talking in time division multiplexes, what we saw is for each and every channel, different time slots are given. So he or she can stay at the same time. But in frequency division multiple access, here we are going to provide some different frequencies for the communication, but he can stay at the same time. Okay, so at same time, he can tune on to different frequencies. That is what he can tune on to different frequencies. For example, the best example is a radio station. Okay, at the same time, he can switch on to different frequencies of radio station for listening to different programs that is being telecasted. Okay, the best example of this frequency division multiplexing is the radio station. Okay, so your channels can be assigned to the same frequency at all times. So here, so this particular concept we call as pure frequency division multiplexing. Okay, so in detail, when we study about, there are much more talk about this, but this session is not giving that much time to learn more about this FDMA or TDMA, or next is something about the CDMA or something like that. Okay, so here so the channels will be assigned with the same frequency but all the time. So this is something what is called to be as the pure frequency division multiplex access, or we can change the frequency according to certain pattern that is needed. So that concept we can call as frequency division multiplexes combined with time division. If you're going to be the same time, if you're going to only changing the frequency and using this at all time, in the sense that is pure FDMA. If you're going to change the time as well as change the frequency, then we can say this particular concept as frequency division multiple access is combined with it of the time division multiple access. Okay, so here from this slot, it has been clearly said that the channel spectrum is divided into certain frequency bands. So that, as I said, certain frequencies are being allocated for each and every channel, for each and every channel, right? So here channel spectrum is divided into certain frequency band, and each station is assigned with some fixed frequency band for its transmission. So the unused transmission time in frequency bands will become more idle. So example, when you're talking about, when you see the example of this is there are about 6 stations, and again the same station like 1, 3, 4, I have the packet for the I will have a packet and it go for the transmission, whereas the packet of 256 the frequency band is found to be idle here. Okay, it is say the lines are just a simple straight line. 256 lines are straight line, whereas we can see there is a packet for the 1, 3, and 4 at different frequency band they can able to transmit. So if we can using some different frequency band, we can also avoid some collision. If all these three nodes like the LAN 1 and 3 and 4, if they started to packet at the same frequency, then there is an interference will happen. Okay, same frequency, then interference will happen. So if you are using different frequencies for transmission, then there will be no interference and then there will be no collision to happen. Okay, so that is all the responsibilities of the MAC protocol related to how we are allocating the channels for the communication and accessing the media. Okay, so next something about the we are dealing with random access protocols. Okay, so we can talk something about the CDMA also, but this CDMA code division multiple access is of various. Very big topic because it uses different types of code instead of a frequency division and multiple and the time division. It uses different frequency code for transmitting of the data, and each and every channel is allotted with a certain code for its transmission. So it is a very vast topic, and let me see that CDMA alone in a different class. Okay. Now let me see something about the random access protocols. Random access protocols is when a packet uh, when a node has to when a node has packet, when to send that particular packet. That is something about the random access protocol. Okay, so when it has its opportunity or when it has needs for sending that particular packet, that is something about the random access protocol. Okay, so when two or more transmitting the nodes at the same time, then automatically then there is a collision will happen. Okay, so what happened to do in the sense we have to detect the collision and we have to recover from the collision. Okay, so there are various protocols because as I said, this random access protocol or the protocol where there is a possibility of contention to happen. This is because this is a contention place. Okay, so if it have a packet, it will send the packet. So then there's a need to take some keen responsibility or keen knowledge of how to allocate the channels, how to allocate the medium for the different nodes to transmit. Okay? Because there is a possibility for contention here. So random access protocols, there are various protocols that is being supported here. So let me see the sorted Aloha, CSMA, CD, and CSMA, CA. So let me see these protocols one by one in random access MAC protocol. Okay, so the evolution of these conduction protocols. So the very first was the Aloha. It was developed in the 1970s. This particular packet for the rail network. Okay, this was the very first protocol that is being started. The next implement to this Aloha only we go for the slotted Aloha, where it starts its transmission only at the fixed time slot. Okay, so and implement to the slotted Aloha we go for carrier sense multiple access. Okay, so here it starts its transmission only if there is no transmission is ongoing. If there is no transmission, it starts its transmission. And again, an advantage to it, or again an improvisation to it, is the carrier sense multiplex with CD, that is collision detection. So here it stop ongoing the transmission if suppose if there is any collision happens. Example only we saw can see this type in the Ethernet. Okay. Whereas in your wireless, we can see for carrier sense multiple access collision avoidance. What are the different ways we can able to avoid the collision? CA. Okay, this is also another protocol that exists. Okay, in wireless communication, CSMA by CA. Okay, so let me see the protocols one by one. Okay, so in starting about this Aloha protocol, it uses an acknowledgement to confirm the success of the project. Okay, so here talking about this Aloha protocol, it was developed by the Abramson in the 1970s for the packet radio network by Hawaii University. So here they are saying what is this Aloha protocol? Whenever a station has a data, it transmits immediately. Okay. So for example, if a station it has its data, it will transmit immediately. So sender finds out whether the transmission was successful or experienced collision by listening to the broadcast from the destination station. Okay. So here the sender retransmits after some random time if there is a collision. See the pure what happens if it has a data, immediately the sender will transmit the data. So only it will check whether only the transmission was successful or not. Okay, so here if it experiences any collision or any happens, only it will be checked by the receiver at that the destination station. It will find out whether there is any collision on transmission. If there is any collision on transmission, again the sender has to retransmission of data. Okay, this was the first technology that has been opted. Okay, if it has the data, it will send, but it will if there is any collision happens, because at the same time multiple stations started sending the data. Okay, so what happened in the sense, then surely then there will be a collision happens. If multiple stations start sending the data, then there will be some collision happens. So if there is a collision, and again the station has to resend the data, so this will go on. Okay, so this is something about the in talking about this pure Aloha. systems. Okay. Next up, this there are two versions of this Aloha. One is as I said, is one. This is a pure Aloha. Another one is the slotted Aloha. So pure Aloha, as we said, if it has a station, it will send. Okay. Here, then talk. Next is something about the slotted Aloha. So one is the pure Aloha. Another one is the slotted Aloha. So in slotted Aloha, what this is in slotted Aloha is it is an improvement to the pure Aloha. So here is time is slotted and a packet can only be transmitted at the beginning of one slot. Okay, so the slotted Aloha here, what happens in this is time is slotted and a packet can only be transmitted at the beginning of one slot. So normally what happens in pure Aloha, as I said, the day station will send the data once it has the data, but here it is not like that. The slot, there is a time slot has been given, so only the station can send at the starting of the time slot, at the beginning of the slot. Okay, so by doing so, the direct collision, the happening of collision has been reduced. The happening of collision has been covered. So in pure alpha, it has been found there are some about 10 to 80% of collision. That will be reduced to 60 to 70. That's it. Some there is reduction in the collision. That happens at the slotted alpha. Okay, so in both the cases, so this is a frame transmission diagram of this pure Aloha, how what happens in this pure Aloha. So here, what happens in this diagram, if you see in the in pure Aloha, whenever any station transmits a frame, it expects the acknowledgement from the receiver. Whenever station transmits a frame, it expects an acknowledgement. If the acknowledgement is not received within a specified time, so what happens? The station assumes that the frame has been destroyed. So okay, this is I'm talking about the pure alpha. Okay, if the frame is destroyed because of collision, the station has to wait for the some random amount of time, and then it has to send again the particular again. This waiting time must be random, otherwise same frame will be called again and again. Therefore, pure alpha dictates that when timeout period passes, each station has to wait for random amount of time before resending its frame. Okay, this randomness of sending this data will help to avoid some collision. Okay, so here in this diagram, we can see there are of about four stations are transmitting the data. In this figure, there are about four stations that transmitting data. So each and every station is transmitting some frame. So for example, if station one have transmitted frame one, frame two, and frame three. Okay, so what happened in the sense in this the at some point of time it has been found that at the same station two, the frame one that the frame two, okay, the frame two of station one as well as the frame 2.1 of station frame one of station two and frame one of station three as well as frame one of station four has been found to be collided. Okay, so what happens? The collision happens here. So normally we can see this yellow color. It represents that the collision. Okay, so this for the station one, the second frame of station one, and the first frame of station two, three, and four. When at the time of transmission, because this is the time it got this data, so it is transmitting at this time. So at this time, what happens? And that there is a collision happens. So that is the something about the pure alpha. If it got the data, it will send. It will not bother about whether there is collision or not happens. If suppose if there is no acknowledgement for certain period of time, it has to wait, and then it has to again it has to retransmit the data. Okay, it has to wait for a random amount of time, and then it has to retransmit the data. So in order to by doing so, what happened in the sense? So the foundation of the founding of collision has been is founded to be gradually it has been increased. So as a remedy to it, only we go for something what is called to be as the slotted alpha has been came. Okay. So next we are going to see the throughput analysis of this pure alpha. So we are going to see the throughput analysis of this pure alpha. So throughput from this throughput analysis, it has been from frame. The red color it indicates the frame that is being collided at the starting of the frame as well as at the end frame. So totally the entire frame is being collided. So the frame that will be collided can only if another transmission begins in this vulnerable period of time. So why this collision happens? Why this collision happen in the sense because there is another station that transmitted the same time of T naught to T naught F, T naught plus F. So that is the reason why this collision happens. Therefore, from this we can able to know the vulnerable period has a length of two frame times. Okay, there. So because this one is T1 naught, another one is T naught plus F. So this vulnerable period is based upon this two frame times. Okay. So from this we can solve a problem. What is the vulnerable time of example? Okay, so this is a vulnerable time of example. If a pure Aloha has a transmitter of 200 bit frames on a channel of 200 kilobits per second, what is the requirement to make this frame collision free? So how I can able to make this collision free? So here the solution to it is nothing but, so here normally what happened in the sense of the average frame transmission time will be the is 200 bits by 200 kilobits per second for, you can say, 1 millisecond. So normally when you divide this, you get 1 millisecond is the average frame transmission time. What is the vulnerable time? Vulnerable time, as I said, it is 2 frames. Okay, the previous slide, as I said, the vulnerable time for this pure Aloha is nothing but it is 2 frame times. Okay, so from this, what we are going to do this, we are going to calculate. So actually, we found that frame transmission is 1 millisecond. So the vulnerable time is 2 into 1 millisecond. We'll get 2 millisecond is the vulnerable time. So this means that no station should send later than 1 millisecond. So 2 millisecond is the vulnerable time. So from this, in order to make it a collision free, so what we have to listen that no station should send later than 1 millisecond or before this station starts transmission, or no station should start sending after 1 millisecond. So by doing so only we can able to avoid the collision free. In the case of this pure Aloha. Okay, this is an analysis example to say when by using pure Aloha, how we can able to solve the problem of this collision. Okay, next the throughput analysis of this same. Okay, so here from this, for the pure, it's the same for the pure Aloha. The throughput, the average number of successful from transmission time for the is represented as S. Okay, the throughput, the average number or the successful frame transmission is represented as S. As well as G is represented to be the load for the transmission take place, and the average number of transmission attempts it has been done by each and every node during one frame transmission time is represented as the G. G is the load and S is the average number of successful frame transmission. Okay, throughput, or we can say successful frame transmission is, and G is the load or the average number of transmission attempts have been made by all the node. So with this, we can able to get a big formula. Okay, so the throughput analysis, another formula is the formula of the probability of success formula. That is the probability of the frame transmission when the probability of the frame transmission is successful if there is no additional transmission in the vulnerable time. So what is this in the sense? The probability of K transmission attempts during the vulnerable period is P of K is equals to 2 into G, that is the load, to the power of K, and E to the power of minus 2G by K, probability of K factorial. Okay, so this is the formula for the probability of K transmission attempts that happens at the time of vulnerable period. And what is the probability of success is nothing but P of 0, and that is equals to E to the power of minus 2G. And what is S? S is nothing but the average number of transmission attempts to be taken. S, that is S. The S is equals to, average successful transmission is S. So S is equal to attempts taken into the probability of success, that is equals to G into, we know that probability of success is equal to E to the power of minus 2G. So G into E to the power of minus 2G will give you the successful transmission of, takes place in the case of pure Aloha. In pure Aloha, the successful transmission takes place S is equals to G into E to the power of minus 2G. So this is a formula. This is a general formula that you have to know. Okay, capital S is the successful transmission of data frame happens in the case of pure Aloha. Its formula is G into E to the power of minus 2G. Using this, okay, so this is a throughput analysis graph that has been shown. Okay, so for if suppose if for small G, if the load is very, because attempt to make it is small, then the successful transmission is approximately is equal to delta G, because there's really no collision happens, and S is also small because of the load is small. Because load is small and S is also successful attention is successful transmission is also small. If suppose if the large, if the load is large, and of course what happened in the sense, then as load increases, then successful transmission will decreases. Normally gradually it will decreases, load increases, and then the successful transmission decreases, and then there will be and S will become more small because of collision happens. So this is another throughput example for the Aloha throughput example. Okay, these are some big questions only. So throughput example related to the pure Aloha. So pure Aloha network transmits of about 200 bit frames on a shared channel of 200 kbps. What is the throughput if the system produces 1000 frames per second, or 500 frames per second, or 250 frames per second? So we have to calculate for each and every frame per second. For the if the network transfers 200 bit frame on a shared channel of 200 kbps of speed. Okay. So if the system creates 1000 frames per second, then there will be of one frame per millisecond. This is one frame. So 1000 frames will be equal to one frame per millisecond. The load then the load will be equal to one. So what is the formula? As I said, the successful transmission formula is S is equals to G into e to the power of minus 2G. Okay, so by doing so, we get the formula S is equal to 0.135, that is 13.5%. So this means that the throughput is 1000 into the throughput, that is because they ask for 1000 frames per second, right? That is the throughput. So 1000 into 0.135 will give you 135 frames. The successful frames transmission is 135 frames. Okay, so only 135 frames out of 1000 frames will probably survive, and that is a successful transmission of frames in the case of 1000 frames per second. Okay, so next is the if the system creates 500 frames. Okay, if the system creates because 500 frames per second. Okay, if the system creates 500 frames per second, then this is half frame per millisecond. This is half. Okay, before it was one, and if it is half, then the load also will be equal to half. In this case, what is the successful transmission is SD into e to the power of minus 2 is 0.18184 or 18.4%. Okay, this means that the throughput is will be only of half, that is 500 throughput, because only you have same 500 frames per second, right? So 500 into 0.184 will give you 92, and that means that there is only 92 out of 500 frames will survive. In case of 500, only 92 frames will survive. Okay, this is the maximum throughput case in this particular problem. Okay, because out of 500, 192 frames have been survived. If the system creates 250 frames per second, and what happens then? There is only one-fourth frame only per millisecond, then the load is also will be one-fourth. And if you go for the formula S into G into e to the power of minus 2G, then you get S is equal to 0.12, that is 15.2 percentage. Then the throughput for this 250 frame is into 0.152 will be, we have only 38. So out of 38, only 30 frames out of 250 will probably survive in the case of this pure alpha. Okay. So these are some of the problems discussed that has to be known related to the successive transmission of the form S is equals to G into e to the power of minus 2G. Okay. So some of the gate questions while solving this. Okay. So considering a network of pure Aloha medium access control where each frame is of about only 1000 bits, channel transmission is also given that is 1 megabits per second, and aggregate number of transmission across all the nodes is managed to as Poisson process with a rate of about 1000 frames per second. And throughput is defined as the average number of frames successfully transmitted per second. The throughput of the network is, what is the throughput? They are asking for the throughput. What would be the throughputs? Okay. So here by so doing so, we can say that it is 132 140. Okay, because answer is 132 140 because that throughput has been calculated. So when you go for this solution to it, so we know the formula for this efficiency formula, that is pure formula. Pure alpha is G into e to the power of minus 2G. So and by doing so, we are trying that because all these things have been given, the bandwidth and all these things has been given in previous thing, that is L and bandwidth time, all this given. So it is nothing but it is 1000, length is 1000 bits per second, and with the transmission rate of about 1 megabit, that is into the power of 6 bits per second. So that is what they are given here. So L by B, that's 1000 by 10 to the power of 6 will give you 1 millisecond. So for 1000 frames, it will be 1000 into 1 millisecond, that is equals to 1 second. So now what they are saying is you have to check for 1 second total of 1000 frames. So G is equals to 1. And the value of E is, I think it is 2.7. We all know it. By mathematically this, we know that the value of E is 2.7. So what is the efficiency is nothing but 1 into, that is the capital G is 1, right? So 1 into 2.71 to the power of minus 2 plus exponential of this 2 minus 2 plus 1 will give you something of about 0.1353. So now for 1000 frames, it is being known that 1000 into 0.135 will give you 135.3. So it is closest to 135. So the throughput, the number of frames for out of 1000 frames, it is being known that it is 135 frames. Okay, this is a general gate question. Okay. Now we are going to see something about the slotted Aloha entity. Okay, we are going to see something about the slotted Aloha. Okay, slotted Aloha was invented to improve the efficiency of this actually for the pure Aloha So because as a chance of to improve the in order to reduce the collision. Okay, since collision is very high in the case of pure aloha, we go for this slotted aloha. Okay, in slotted aloha, what happened in this is the time of the shared channel is divided into discrete intervals, what we call to be a slot. Okay, why the name slotted aloha in the sense here the time the shared channel is divided based on some set of intervals, and that is what called to be as slots. So okay, so by means of what they are saying, the station can send a frame only at the beginning of the slot, and only one frame will be sent at each slot. So this is a rule that is being set. So by set up in this rule, only it has been found that the collision has been less than compared to that of the pure Alaha. Okay, the station has to send only one frame at the beginning of the slot, and only one frame should be sent in each slot. Okay, so from this figure, there are of about again four stations. Okay, so if in slotted Alaha, what is saying, if any station is not able to place the frame onto the channel at the beginning of the slot, then it misses that time slot. Okay, because as I said, slotted Alaha, the frame has to be sent at the starting of the frame. If any station misses, then it misses the entire slot. It has to wait until the beginning of the next slot, and there is still a probable possibility of collision to happen if two stations try to send at the same time. So that is where the collision happens. See, in the previous case, we can see the collision happens in the only four frames. There is collision with the four frames, but here see only there is collision with only two frames. Okay, so it's not at all the we see only at the collision happens only for the two frames, not as the top that we have seen in the uh, pure Alaha. Okay, so here from this we can see from this diagram the collision has been reduced to one half. Yes, right? Because four frames it has been there's only two frame collision, but remaining frames has been sent as it is. So this is a throughput analysis for the slotted Alaha, the throughput analysis. So in this throughput analysis, it has been found that the total frame, how do they are getting, because in the previously in pure alpha it is found that g into 2 to the power of e to the power of 2 minus 2g. Okay, so now it has been sent to half of it. Okay, so then the vulnerable time is been found to be very less compared to that of the previous. Okay, it is only before there is of vulnerable time is 2. Okay, now here the one of time is only one. Okay, because you see only we can see only there is only one set of frame is being affected and not the other. So the vulnerable time is divided into one. So that is why they are saying S is equals to G into e to the power of minus G. Okay, that is the throughput analysis for this slotted alga, since it is being found to be less. Okay, compared to the top the pure vulnerable time it was 2 frames per second. Now we here it is reduced to half, right? So from this, they have been the efficiency of the successful transmission S is equals to capital G is the load, so G into e to the power of minus G. So this is the analysis graph of the pure as well as the slotted Aloha throughput. So here from this graph itself, we can see the improvement of the slotted Aloha compared to that of the pure Aloha. Okay, so the green color is represents the slotted Aloha, and the red is represented as the pure Aloha. So it has been improved a lot to of about 0.368, whereas in the case of it is only 0.184 in the pure Aloha. Okay. And again, there is another set of questions. In the slotted Aloha, the network transmits as 200 bit frames on a chat channel of 200 kilobits. What is the throughput if the system produces 1000 frames per second? So the same formula for applying the same formula, 500 frames and 250 frames. If there's 1000 frames, then S is equals to G into e to the power of G, or S is equals to, we get 3.368, that is 6.8. Then we multiply with 1000, we get 368 frames. So out of 368 frames, 1000 frames only, out of 1000, 368 frames has been successfully transmitted. But when we saw in that pure Alaha, it is only 135 frames. Okay, 135 frames in pure Alaha. That is only 135 frames out of 1000 frames as successful transmission. But in this case, we can see 386 frames out of 1000. See how much of difference 135 and 386. That is something about the some improvement that is made in the slotted Aloha. Okay. Next, of about with 500 frames. In talking about this 500 frames, Again, what happens? Again, applying the same formula, it has been found that it is 151 frames in the has been okay. 151 frames out of 500 has been successfully transmitted, but in that it has been found that only 92 frames. Okay, only 92 frames has been successfully transmitted. Okay, but here in this case, we can see that 151 frames. See the difference, 92 and 151. So that is something about this slotted Aloha. And again, for the same in the case of 250 frames, so it has been found that only about 49 frames out of 250 frames has been survived. Whereas in a pure Aloha, only 31 frames has been survived, has been successfully transmitted. But in slotted Aloha, it has been found of about 49 frames out of 250 has been survived, right? So this is something about the improvement in the slotted Aloha. Okay. So next is the we are going to see carrier sense, multiple access, very important topic. Carrier sense, multiple access. This is one of the important topics that you have to know. What is this carrier sense, multiple access? Okay. So talking about this carrier sense, multiple access. So what actually they do in the sense they will for each and every time at the before of transmission, each and every station has to listen to the particular sense of carrier. Okay, whether the channel before of any transmission. Okay, it listens before of any transmission if the channel is idle or not. If the channel is idle, it transmits the frame. If the channel is busy, it will defer the transmission. This is normal. This is carrier sense before talking or while talking. So whatever it is. Okay, the M nodes, it will sense the medium. Whatever the medium it wants to transmit, it will sense the medium. Okay, it will sense the medium whether we can able to send data or not. If the medium is busy, if the medium is busy, it will not send any data. It will remain as it is. If the medium is idle, it will send the data. Okay, so this is so generally here it deals with sensing the carrier and accessing the medium. Okay, that is something about the carrier sense. It sends the carrier, it sends the particular medium before of any transmission. So by doing so, normally what happens, we can see the probability of collision detection is decreases. Okay, so because it will in slotted Aloha, what happens? What we saw in essence at the starting of the time slot, all the stations have started sending the frame. So there is some, although the collision has been decreased in capacity of the pure Aloha, although we have some collision, okay, but that is also being improved by means of carrier sense multiple access. What happens? It will before transmitting, once it gets the station, once it every station once it gets the data, it will wait, it will sense the medium, whether the medium is free. If it is free, it will send. If it is not free, it will wait until the medium is free. It will wait and then it will send the data. So the probability of collision gradually it will decreases. Okay, gradually it will decreases. So that is a speciality in this carrier sense multiple access. Okay, so in carrier sense multiple access, we can go with carrier sense multiple access collision detection. If suppose if there is any collision happens, there's a possibility also to detect whether there is the collision happens. That is something about this carrier sense multiple access with collision detection. Okay, so what we do with the carrier sense multiple access with collision detection in the sense here, the collision will be detected within a very short period. Suppose if there is any collision happens, it will be detected within a very short period of time. And what happens in the sense, once the collision is detected, either it has to read transmission of this particular packet. Okay, this collision detection is easy in the case of wireless, but in the case of in the wired network, this collision detection is very easy. As I said before, in wireless, that is where we go for carrier sense multiple access with collision avoidance. We go for collision avoidance than with the collision detections. So because detecting the collision in wire network is quite easy, sensing. But in the case of wireless, this in air, it is not possible, or in space, it's not possible to detect whether the collision happens or not. Okay, so only thing what we can do in this is we can only able to avoid the collision. We cannot able to detect. We can only able to avoid. So that is why they are saying here So CSMA CD is probably it can be used for wired network, and the CSMA CA can be used for the wireless. Okay. This is a collision that happens in carrier sense multiple access. This is a statistical diagram that has been representative that happens of collision that is to be happened here. Okay, so here there are of about four nodes A, B, C, and D. Okay, so A I have this is the blue color. They are representing the transmission, the signal range, the transmission range of B. So B signal is exists up to A, as well as B signal also exists up to D. In the case of C also area where the C signals can be exist as well as C can be existed. See, so this what happened in the sense the both the signal I mean the transmission medium of the B and the C and the has been given in detail. So there is a possibility for the area where the C signal can able to C and the B. So the ash represents that is the region. The ash region represents the region where the signal of C and as well as the signal of B to get collided. Collision happens. Okay, these are the region where there is a collision could happen. Okay, that is because since the transmission range of B and C are known, so the area where the signals that is to be transmitted are collision happen. This is normal. This is something about the carrier sense multiple access in case of collision. So how to find out the vulnerable time in this collision? Okay, so when talking about this vulnerable time in the sense, it has been found that the vulnerable time is equal to that of the propagation time. That is, the frame propagation time is most probably is equal to that of the vulnerable because each and every station can able to sense the other stations at the time of sending the data. What happens in the sense that collision happens. So the propagation time of the say, data is equal to that of the vulnerable time. Okay, so that is something that is the probable in problem with that of the carrier sense multiple access. So say since vulnerable time is equal to that of the propagation time. Okay, so this is something about the persistent methods that is to be followed in carrier sense multiple access. We have some certain method, one persistent method, non-persistent method, and C persistent, P persistent method. So these are some of the persistent methods that is to be known. Okay. Uh, so because why we have to go to these persistent methods? Because carrier sends, it waits, and then when it is free, it will send the data. Okay, so it has to how much of time it has to wait. There are several versions. These represents the versions of CSMA. The time period it has to wait, and then it has to send the data. So these are the several versions of CSMA. Okay, one persistent, non-persistent, and P persistent. In talking about this one persistent, so in systems, all stations in the system, the all the station that is wishing to transmit, it has to access the medium at the same time as soon as it becomes idle. Okay, so that is something about the one person. See from this diagram, if the system is busy, it will wait. If the system is idle, then it will send the data. All the station will send which that wishes to transmit the data, it will send the data. That is something about the one per system. So until the system is idle, it will, I mean, until the system is busy, it will wait. If it is idle, it will start sends the data. That is something about the one persistent CSMA. Whereas in the case of non-persistent CSMA, the station will sense the carrier and start sending immediately if the medium is idle. Okay. So here, what they do is, if they suppose if the medium is busy, the station has to wait for a random amount of time before sensing the medium, and again and repeating this back. Okay, so here, what does it mean in the sense here in non-persistent? It has to wait. So it will wait, and then it will find if the station is idle. Then only it will send the data. But that is not the case of one persistent. It will send the data. Okay, if it is B, it will continuously send it to BC and until it will send. Whereas in the case of non-persistent, it has to wait if the station is busy and idle, and then after a waiting of 1 minute of time, it will send. Okay, that is non-persistent. Immediately sending is one persistent. It wait and then sends the medium and then it will send. Wait for a short period of time and then sending the data is something about it non-persistent. And next, in talking about the P-persistent CSMA, it is a system know that it sends the medium but only transmits with the probability of p second. If the station have to reschedule to the next slot with the probability of p, it has to access in this slot for in addition. Okay, so that is something about the p persistent. So here it has to wait for probability of time, some certain period of time. Apart with the random amount of time, it has to wait for some back of time. That is the probability of time. It has to wait, and then only it has to send the data. See, in the one persistent, what is said in the sense, the station has to sense the medium. If the medium is busy, wait. Once, if it is idle, it will send. That is one persistent. Whereas in the case of non-persistent, if the station is busy, wait. If the station is idle, it will wait for a few short period of time and then it will send the data. That is non-persistent. Here, in P persistent, what it has to do in the sense, it has to wait. If the station is busy, then if the station is idle, it has to wait for a short time slot, and again it has to wait for a propagation of time, that is the back of time, probability of time, and then only it has to go on with the transmission. So by doing so, what happens in the sense, the probability of collision happens will decreases. So that is the concept with this CSMA by CSMA, persistence method. Okay. So this is something about the diagram of when this collision happens in CSMA in collision detection. So because there is a possibility to find the collision detection that happens in your wire systems when this collision happens. This is that is something about this collision of CSMA in the case of collision detection. Okay. So by seeing this, we can see that the A, B, there are four stations, and the station one is transmitting the data. It's entering the first bit A to D. So the data has been transmitted with no collision. But what happened in the sense, at the same time, C is also sending its first bit to D. Okay, C is also sending its first bit to D. That blue color is the C. So what happens in the sense, there's a possibility of the A's data as well as the C's data to get collided at one point. Okay, so at one point both the data has been collided, and that collision is detected by the C, and the same time this collision is also detected at the A. Okay, so the transmission time of A and C when we talk about is nothing but it is T2. Okay, T2 and T3 are the transmission time of this collision. Okay, as we're talking about this transmission time of A to D, that is A's transmission time is only is T2, and T3 is only the transmission, because the collision happens. Once the collision is detected, what happens in the sense and automatically A has to resend the data and C has to resend the data using this persistent method. They can use one persistent or non-persistent, and P persistent method has to follow some technique and has to retransmit the packet. This is of collision it happens. So this is the flow diagram of how carrier sense multiple access happens in collision avoidance. Because as I said, in wireless we can only go with collision avoidance. We can able to avoid the collision, but not we can able to detect the collision. So this is of diagram of carrier sense multiple access is how we can able to avoid the collision. Okay. So before seeing, let me see some of the notes. Let me take a notes on K represents the number of attempts it makes to make collision, and T of B is the back of time it needs to wait for the packet to be sent, and IFS is the small waiting time, that is interframe space we call as I said before, it has to wait for a short period of time. That is what is called to be as interframe space, and request to send. If it wants to send the data, it has to send something what is called as request to send. If it wants to if it have sent the data, if the receiver wants to receive the data, then it will send clear to send. Okay. That is, if the sender will send request to send, if he wants to send the data, and the receiver will say, okay, I'm free, you send the data by saying that clear to send. Okay, these are some of the small notes that you have to know before going on with this transmission that happens, at what has happened at carrier sense multiplexer with collision avoidance. Okay, so initially what happens if the channel is free? Okay, if the channel is found to be the first attempt, if you take the 0th attempt on the first attempt, if the channel is free, so what carries in some multiple access that happens in wireless, I'm talking about wireless, and that is with the data that to be transmitted in space, it has to wait for a short period of time. That is what is called to be as interframe space. The because choosing a random want a random number of this space, you have to choose a random number of r that should be between the two to the power of k minus 1, not because not to avoid some collision. Okay, we have to wait. And then before sending the data, we have to send something what is called as send RTS, request to send. Whether I can able to send the data. It is asking something of question like RTS to the receiver. And what the RTS has to do, it has to set a timer. Okay, before sending that RTS, it will set a timer. Okay, because it has to receive clear to send from the receiver, right? So it has to send the receiver. So if the receiver clear to send is being received within the time slot, then it has to wait for another very short period of time. Then it will send the clear. If suppose if the receiver have not received send the clear to send within the time span, then automatically it has to go on with the second chance of again waiting and then taking the option and send the RTS once again. Okay, this is the something about the clear to send. So when the clear to send is has been received within the time, then automatically again have to wait another interframe space. So totally two interframe space it is waiting, and then only it has to send the frame and set the timer not to receive the acknowledgement. If the acknowledgement received within this time, then can start sending the another frame. If the acknowledgement is not received, again it has to resend the same frame. This is the flow diagram how data has been transmitted in the case of carrier sense multiplex with collision avoidance. We're just avoiding the collision by doing some certain steps. Okay, so I think so. We have seen some of the methods. So this is a random access method from the starting of Aloha, pure Aloha carrier sense multiple access with collision and carrier sense multiple access with collision detection and the carrier sense multiple access with collision avoidance. We have seen some certain steps of this random access method. So these are the possibilities of contention to happen. And now to avoid these contentions, what we have to do, what we have to follow up is very, very important. Okay, so this is something about the and in the case of this random access method. Okay, next we are going to see on the next method is something about the okay, this is again the contention method. We're talking about the okay. Next is collision contention interval. Okay, this is the interval of time when the contention happens that is being given. Okay, let me see the next thing, that is controlled access. Now we are going for the controlled access, that is the reservation access method. Okay, the controlled access method, the reservation access method. Okay, very, very important. Reservation. So what we have to do here, okay, reservation access method. So here what happens in the sense, reservation has to be made. So here first one is a reservation access method. Control access method, we have seen three methods: reservation access method and token parsing and polling. Okay, these are the three things we are going to see. In reservation access method, so what we are going to do, we are going to reserve some time slots for the channel to send the data. Okay, we have for reservation is very, very important. So that by reserving some certain types of, we can avoid some certain collision to happen. So by doing some reservation, we can avoid some certain collision. So reservation has to be done in prior before sending the any station. So if reservation done, then there will be no step. So certain time slots. So reservation frame will be sent for each and every time period. So for that, for the reservation base, certain time slots will be sent like 0, 1, 2, 3, 4, 5. So what are the time slots it is being reserved and which particular time slot it is free. Okay, so the reservation frame has been sent by each and every station. So based on by the channel. Okay, based on that reservation, the channel will take its opportunity to for transmitting the data. Okay. Okay. So by doing so, what happened in the sense? So here, average waiting time before transmission will be found to be n, and the load utilization is also found to be not good if suppose if the n is large and high. There will be some high load happens at this case. Okay. So here in this reservation frame, the station one and then will reserve some of about n bits, and some D bits will be reserved by that of the station 4, and station 3 and station 1, it has to wait for its own slot. Okay, so for each and every time slot, once the particular station has completed, it will that particular slot will be freed and it will be given to other station. So for example, in this case, so 5, 4, 3, 2, 1 are reserved and one is free. So station 1, next, the opportunity will be given to the station one. Okay, station any station, if it wants to reserve use this particular time slot, it will reserve and use this particular time slot. Okay, so this is in this case. At the see at the reservation frame, what they are saying is, so the fifth slide slot and second slide slot is reserved, and the remaining time slot is free. So any station, if it wants to reserve and it wants to send a data bit, it has to reserve for 4, 3 as well as 1, and then it can go with reservation, and then it can at that particular time so it can start its transmission. So this is one of the best method of using. This is a controlled access method. Okay, another way of control access method is the polling. Okay, this is another important thing, polling and selecting the option. Okay, polling and selecting. So what is this polling? We all know what is polling. Polling in the sense selecting a particular channel. Polling by selecting particular node for sending the data. That is something what is called to be as polling. We all know about this polling method. Okay, we are going to, okay, and selecting is the poll. So here the master, that is the primary data as well as the primary device and a master device. And the master device, primary device, what it will do in the sense, it will poll the secondary station. So that is something here. That is what they are given here. Okay, polling here is the primary station will poll and it will select the secondary station for the transmission to happens. Okay. The primary, so here, when you talk about primary, there will be only one primary and there will be multiple secondary devices. It consists of single transmission line, and all the exchanges are made only with the primary devices. So as I said, the primary will take the control of calling the respective secondary stations. So it will select. So in the second diagram, it has been given that the primary, firstly, it will select it, calls the station A, and the pulse station A. If station A is not in a respective, if it does not have any data to transmit, it will send a negative acknowledgement to the primary station. Once it sends a negative acknowledgement to the primary station, what primary station will do in this? It started calling the other station. So what happens in the sense, the primary station, it will now it will pulse for the station B. Okay, so once if the station B has the data for data transmission, automatically it will send the data to the and the acknowledgement will be exchanged. So all these data exchanges are made through the primary devices. So primary devices takes control and then initiate the session in this polling method. So that is something about the polling and selecting. So this is one of the another control access method other than that of the reservation. Reservation, what we do, we reserve and then we go for the transmission of data. But here in polling and selecting, there is a primary to select another one of the secondary station for sending and then transmitting of data. Okay. So so what is the in-depth thing about this polling is in the sense is it offers of higher efficiency than that of the random access protocol, because we know that random access protocol is a conduction protocol. Okay, and this control access polling method is of higher efficiency than that of the other, because why the drawback here in polling method is it's delay. The delay in selecting the secondary station, because some station because it will select a station, and if that station doesn't have any data to transmit, then that is a waste of time. Then it has to go and select the other secondary station. That is the delay in selecting the station. And the node transmission time is also very less in copper, that is only RBPS. And the channel becomes inoperative if the master devices fails. If there is no primary, then every entire system will goes off. Okay, so there are four protocol issues here. So if only one node is sending, then the throughput will be R. If there are many nodes have to send that, then the throughput will be R by L. And if it is a decentralized protocol, there is no one, then it will be null, and it is simple and inexpensive to implement. Okay. Next method is the token passing method. So in this case, what happens in this is, as a token of a small packet will be circulated around the network throughout the computer. So what happens in this is the station that has that particular receives the token will have the opportunity to transmit the data. If that particular station if does not have any data to transmit, then it has to circulate the token to the nearby station. So this is that a single packet of token will be circulated around. So this is also another control access method. So when talking about the start, when not talking about the flow chart start, we have to wait for the token. If it captures the token, then what it has to do in this is it has to send the frame. Okay, if it has a frame, it will send the frame and it has to wait for the time expired. It will send until the time expired, and then it will release the token to the next station to send. If it does not have any frame, automatically it will release the frame to the next station. So next station now takes this opportunity of sending the data. So this is in the case of controlled access. Okay. Okay, so with this, we are ending of the session of medium access control. Okay, so today I have discussed something about what is MAC protocol, and we have discussed something about the three cases in MAC protocol. That is, one is the channelization. Channelization, we talk something about the TDMA and FDMA, as well as something about the CDMA, in different multiple access, how each and every channel has its opportunity for transmitting the data. And then we talked something about the random access method. We saw something random access method. So random access method is a conduction method. We saw various protocols like Aloha, and then the slotted Aloha carrier sense multiple access, followed with carrier sense multiple access, collision detection and collision avoidance, where these protocols will work in wired as well as in wireless. We saw some of the examples and analysis. And also lastly, we saw something about the control access method, how we can able to control this access method and provide the opportunity for the other stations for sending the data by doing some reservation and polling and selecting the devices, as well as doing some token passing method. Okay, so and apart with it, we also discussed various gate questions in between, how to the possibilities of gate questions that maybe arise in these sessions. We also have saw in this particular video. Okay, thank you for listening to all. I hope you all do well your great questions in this related topic. Thank you very much. I'm winding up the session. Thank you.